Okay, we kind of already talked about solutions to inequalities, and we're going to continue to see inequalities in this lesson, but we're going to talk about solutions to equations as well. So a solution of an equation or inequality with one variable is a number that can be substituted for the variable to make a true statement. So you saw that with inequalities, and now we'll see that with equations. Take a look at example 1. We have the equation 5x minus 3 equals 17. Well, x equals 4. That is a solution of that equation, because when 4 is substituted for x, it works out. I can put 4 in where x was, so instead of 5 times x, I can do 5 times 4. 5 times 4 gives me 20, and then 20 minus 3 is 17, so that works out because obviously if I have 17 on the left side, that's equal to 17 on the right side. So that makes the statement true. X equals 4 is a solution. In example 2, here we have that inequality again. You see we've got actually variables on both sides. We have 1 plus 4x on the left-hand side, and that's greater than 3x plus 1 on the right side. We're saying that x equals 9 is a solution to this inequality because when 9 is substituted for each x, for both x's, the resulting statement is going to be true. So if you have x, or if you have, that variable in there multiple times, you're going to substitute, 9 in multiple times. So instead of 1 plus 4 times x on the left, we're going to do 1 plus 4 times 9. And of course, PEMDAS tells us to multiply first. 4 times 9 is 36, and then 36 plus 1 gives us 37. So the left side is 37. On the right side, we're going to do the same thing. We're going to plug the 9 in where the x was. Instead of 3 times x, it's now 3 times 9, which gives you 27. And 27 plus 1 gives you the 28. And now look at what you've got. 37 is greater than 28. That is a true statement. So x equals 9 is a possible solution. Take a look at some of these different equations. Well, we have one equation and two inequalities. 7x minus 1 equals 83. 7x minus 1 is less than 83. And 7x minus 1 is greater than 83. What we're going to do is we're going to complete numbers 1, 2, and 3 together. You can do the rest on your own. This is page 225. I'll move this out of the way so you can see that. Page 225 in your workbook. First, in number 1, we're going to evaluate 7x minus 1, which 7x minus 1 is part of every single either equation or inequality. But we're going to put x in for 11. So instead of 7 times x minus 1, we're going to do 7 times 11 minus 1. I'm going to use that substitution step. When I say substitution step, that means I actually show you how I replace the variable with the number. 7 times 11 is 77, and 77 minus 1 is 76. So is that a solution? Is x equals 11? Is that a solution to the equation? Is 76 equal to 83? No. This is not going to work out for that equation. How about, I might even put a slash there, it's not equal to it. How about, is 76 is 76 less than 83? For that second inequality? Yes, it does work out with that inequality. How about the other inequality? Is 76 greater than 83? No. So x equals 11 is a solution only for the inequality 7x minus 1 is less than 83. Now, again, we're still doing 7x minus 1. We're keeping all of the equation and inequalities the same. But now we're going to try x equals 12. So we have to do 7 times 12 minus 1. There's my substitution step. I put the 12 in where the x was. 7 times 12 is going to give me, that would be 84, and then 84 minus 1 is going to give me 83. So is that going to be a solution to the equation? Is 83 equal to 83? Yes, it is. Is 83 less than 83? No, it doesn't work for that inequality. Is 83 greater than 83? No, it doesn't work for that inequality. So that solution, x equals 12, only works for the equation 7x minus 1 is equal to 83. All right, let's try x equals 13 now. What if we do 7 times 13 minus 1? And 7 times 13 is 91, and 91 minus 1, I was going to put the answer there, 91 minus 1 equals 90. So does that work out? Let's see. Is 90 equal to 83? Nope. Is 90 less than 83? Nope. Is 90 greater than 83? Yes. So x equals 13 is a solution to the inequality 7x minus 1 is greater than 83. Okay, so you'll be doing 4, 5, 6, and 7 on your own on page 226. Now we're going to hop over to page 227. Solving an equation or inequality means finding its solutions. Obviously, with an equation, you're only going to have one solution because so that equation is always going to have one solution, but an inequality could have multiple solutions. It could have an infinite number of solutions. So you can solve some equations by thinking about the value that will make the sides of the equation equal, because obviously that equal sign is telling you that the left side is equal to the right side. Take a look at the example here. 2x plus 6 equals 8 plus 6. So you might reason it this way. Both sides have two terms. Okay, you've got on the left side, you got the term 2x and 6. On the right side, you have 8 and 6. On both sides, one of the terms is 6. Do you notice that? This is 6 here, this is 6 here. So right away, you know that those 6's, are equal to each other. They're the same, which means, for the sides to be equal, the other terms must be equal. The 2x and the 8 must be equal. Think of it that way. The 2x and the 8 must be equal. So maybe you can think, okay, 2 times what number is going to give me 8? In this case, it has to be 4. 2 times 4 is going to give you 8. 8 is equal to 8. And that's kind of what they did here. They used the substitution step to check and make sure. So let's go back to the original equation. The original equation was 2x plus 6 equals 8 plus 6. If we put the 4 in where the x was, if I do the substitution step, I'm going to have 8 here, and 8 plus 6 equals 14. And of course on this side I'm going to have 14. And you can see that both sides are equal. The sides of the equation are equal, so x equals 4 is the solution. So now let's look at 11, 13, and 15. You're going to do the rest on your own, but I'm going to help you with some of these because these are a little bit trickier. Here we have 24 divided by 6 on the left-hand side. And on the right-hand side, we have 27 minus x divided by 6. Do you notice how the divided by 6 is the same on both sides? That's already equal. The part that's not, well, I shouldn't say the part that's not equal. The part that is equal, but we don't know what x is the 24 and the 27 minus x. So maybe you can think, hey, 27 minus what number is going to give me 24? In this case, it's got to be 3. 27 minus 3 gives you 24. And we can use the substitution step to check to make sure that we're on the right path. So what I'm going to do is I'm going to go back to the original equation. Let's see, I'm going to use red here. The original equation was 24 divided by 6 is equal to 27 minus, and instead of x, I'm going to substitute 3 in, and then divided by 6. So on 24 divided by 6 on the left-hand side, I'm going to get 4. And on the right-hand side, 27 minus 3 is 24, and 24 divided by 6, there's the 4. So that works out. Let's try the next one. 7x is equal to 7 times 2 to the third power. 7x is equal to 7 times 2 to the third power. Well, do you notice that they have the 7's in common? In this case, on the left-hand side, we're doing 7 times that missing number. And on this side, we're doing 7 times 2 to the third power. the 7s are already the same. The factors of 7 are already the same. But what's different is we've got, x on this side and we've got 2 to the third power on that side. Well, what is 2 to the third power? That's, of course, 2 times 2 times 2, which is going to give you 8. 2 to the third power is 8. Maybe the missing number is 8. Let's try it. Let's check to see if that works. I'm going to erase this. And let's go back to the original equation. 7, instead of 7 times x, we're going to do 7 times 8. And on this side, we have 7 times 2 to the third power. So 7 times 8 is 56. 2 to the third power is 8. And 7 times 8, well, there's your other 56. So 8 was the missing variable. X equals 8. And that works out because both sides are worth 56. Let's do one more. Let's try the 2x plus 7/8 equals 7/8 plus 1/2. Do you notice how the 7/8 are already the same? The part that's different is the 2x on the left and the 1/2 on the right. So you'd have to think to yourself, hey, 2 times what number equals 1/2? Well, hopefully you recognize, if it helps, think of it in terms of money. 2 times what gives you 50 cents? Because half of $1 is 50 cents, right? 1/2 could be represented by 50 cents. So 2 times what gives you 50 cents? Hopefully you think, oh, 2 quarters. And you know a quarter is the same as 1/4. So maybe x is equal to 1/4. 2 times 1/4 gives you 1/2. Let's substitute it into the original equation and see if it works. So I'm going to again go back to the original equation. Let's do red again. Alright, so 2 times 1/4 now instead of x plus 7/8 equals 7/8 plus 1/2. So 2 times 1/4 is going to give you 1/2. So on the left hand side you have 1/2 plus 7/8. On the other side you have 7/8 plus 1/2. And I'm running out of room here, but 1/2 plus 7/8, once you find common denominators and add it all up, you get 11/8, or 1 3/8 on the left hand side. And over here 7/8 plus 1/2, again there's your 1 3/8, so both sides are equal to each other. 1 3/8 is equal to 1 3/8, so 1/4 is the solution for that equation. So here are the takeaways. The solution of an equation is a number that can be substituted for the variable in an equation to make a true statement. And when you're solving an equation or even solving an inequality, that basically means find its solutions. Tell me what does your variable equal? Or could it equal? If it's an inequality, it could have multiple solutions. And you can solve some equations by thinking about the value that will make the sides of the equation equal. Then use substitution to check. That's so very important. Don't forget to substitute what you got for your answer in the original equation to see if both sides are equal, because if they are, then you know your solution is correct.